Okay, welcome to 8D. The last video we did long division. I'm going to do synthetic division here. Synthetic's a little easier. It doesn't always work. Only when you're dividing the factor here, the coefficient is 1 in front of the x. So, which will happen majority of the time for you. So for synthetic division, you take the factor and you change it to the root. So for a factor of x plus 5, the root is -5. That's where it crosses the x-axis. Put it in this little like backwards L, which is we call it like the box. And then what next thing you're going to do is you're going to look at the coefficients. And then, well, let's look at the exponents first. The exponents have to go down each term by 1. So 3, 2, 1, and 60 here is x to the 0 power. So they're all going down by 1. That's very important. And I'll tell you in just a little bit. So next, now you write the coefficients of each term. So the first coefficient's 3, then it's positive 16. Now it's -7, so we just take it as a -7, and a -60. If there, say this middle term was, or -7x wasn't here, and it just went 16x squared minus 60, this x to the first term would not be there. So we're going to represent it in our synthetic division as a 0. So you would represent it as a 0 if this -7x term was not here, but not in this case. So first thing you do, take the first number and draw an arrow, drop it down below a line that you draw. Next, you take the what's in the box, the -5, and you times it by 3, the first number, so it's -15. Now we're going to add. So unlike long division, here we're going to add. So -16 plus -15 is 1. And now I multiply again, -5 times 1, -5. Now we're going to add again. So that's -12. And -5 times -12 is positive 60. -60 plus 60 is 0. This last number is always the remainder. Remainder in our case should be 0, because I will tell you today that anytime I give you a root, it's always, the remainder is always 0. That'll divide out of the polynomial nice and evenly. So when you get a remainder of 0, it divides out evenly. These remaining numbers are your coefficients of your polynomial that after you divide out x plus 5. When you divide a polynomial of x to the third by x, your first coefficient is going to be x squared. X to the third divided by x is x squared. So we have the coefficient is 3 from here, x squared, plus 1. You don't have to write the 1, but x to the first, you don't have to write that x to the first, and then minus 12 x to the 0. We never write that. So this is your new polynomial, and from there you're going to have to use other things to find the solutions. So let's move on. So this is actually 8D here, so solving polynomials. So I'm going to give you a polynomial, and I'm actually going to give you a root also. And from that given root, we're going to find all the other roots. Okay, so I put the polynomial in the calculator, and minus 25. The -5 is a root, so that when we go to graph it, we're going to see that at -5 it crosses the x-axis, so that's good. -5. Let's try to see if we can find the other two. There are 3 solutions to this problem. Let's see, 3 times crossing the x-axis, so sometimes you can get lucky and all of the solutions are rational. So -5 is rational, and we'll see what this number is and this number for the x-intercepts. So how to do that? I go to second trace, 0, because these are also known as zeros, roots, solutions. Left bound, when it's asking left bound, so look from the x-intercept, left would be above in this case. I'm hitting the left key to go above the x-axis, hit enter. Now it's asking for right bound. If I hit the right key, it jumps to the other side of the x-axis, so that's right bound. And yes, just hit enter again. Well, another 0 is at -1, so that's good. That's a rational number. Rational numbers are represented as fractions. Let's go to the second trace, and we're going to find the other x-intercept. So I'm going to the right, and think about from this x-intercept, this is left just a little bit. So the bottom is left. I hit the right key and it jumps to the other side of the x-axis. And what you're doing is you're just going one side and the other, and you're telling the calculator the x-intercept's in between somewhere. So right bound, in this case above, yes, hit enter, and we're at 2.5. So our solutions are x equals -5, x equals -1, and x equals 2.5. I really would like you to not write decimals, so let's change 2.5 to an improper fraction. It's 2 1/2, which is 5/2. You can use the calculator for this. You go 2.5 math. That's change the fraction. A little triangle means change. And there you go, 5/2. So in this case, we got lucky, and you were able to find all the solutions. There are 3 solutions, and they're all rational numbers. So that's good. This doesn't always happen, so let's look at a problem where it might not happen, or it probably won't happen. So example 2, here's your polynomial. I'm giving you a root of 3. So let's put this in the calculator. So it's in the calculator, go to graph it. So one of our x-intercepts is at 3. We know there's 3 solutions. Let's look at the graph. Unfortunately, it only crosses once, and that looks to be at 3. So that's already our root that's given, so we can't find the others. They're not real. They're somewhere else. They're imaginary. So now we have to use this x-intercept to find our others. So let's do it. So your x-intercept's at 3. Your factor is x minus 3. So we're going to take the x-intercept, 3, and put it in our little box. Look at your coefficients of your polynomial. So 1, exponents are going down by 1. X is 0. So we're not going to represent any of the terms with 0. We just take the coefficients. So 1, -7, 19, and -21. Bring down your first term. Multiply. 3 times 1 is 3. Remember, we're adding here, so now it's just adding vertically. -7 plus 3 is -4. 3 times -4 is -12. 19 plus -12 is 7. 3 times -7, 21. -21 plus 21 is 0. Remember, your remainder should always be 0 here. If it's not, something's probably wrong. So you're taking x, or you're taking x to the third, you're dividing by x, so that will remain x squared. So we have 1 x squared. You didn't have to write the 1, but I'm just going to write it just so you can see that 1 comes down, minus 4, bring the exponent down by 1, so it's x to the first power. Not going to write that. And then it's positive 7, so plus 7, x is 0. We don't write that ever. And the remainder is 0. So now we're left with this polynomial that is a quadratic, and we know how to solve quadratics. You can either solve it by factoring. So if you think what 2 numbers multiply by to 7, that'll add up to -4. And hopefully you think quickly, and there's nothing. So we can't solve by factoring. So the only other way I know how to solve this is to use the quadratic formula. So your quadratic formula is a is 1, b is -4, and c is 7. So we use x equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. Get a little crooked here. So 4 plus or minus 16 minus 28. Those of you that know me, I do the exact same thing every time. So these are my steps. 4 plus or minus 16 minus 28 is -12 over 2. Looking at -12, break down 12, because we got to simplify this. So we have a pair of 2's, and we have a 3. So a pair of 2's will come out of the radical. as a 2. Remember, the square root of a negative number is I. Left over is a 3 over 2. We're almost done. Look at you have 3 terms, 4, 2i squared of 3, and 2. Look at your coefficients, 4, 2, and 2. All those are divisible by 2, so let's divide them by 2. So divided by 2, divided by 2, divided by 2. We're left with our solution of x equals 2 plus or minus 1 times I is I, square root of 3, divided by 1. We don't have to divide by 1. So there's your 2 solutions. Your third solution was way up at the beginning of 3 was given to us. So there are your 3 solutions, plus and minus. Okay, come to class with any questions you have. Thank you.